Hi. A test? Hi. Welcome to this video. In this video we'll be solving the Chapter 3 problem here. A company produces steel rods. The lengths of the steel rods are normally distributed with a mean of 243.4 centimeters. So that's the average length of the rods produced by the company, and a standard deviation of 0.8 centimeters. And they want to know what proportion of rods they produce have a length between 241.9 centimeters and 244.3 centimeters. So when might a problem like this show up in life? Oftentimes in quality control and manufacturing, whatever they're manufacturing these rods for. If the rod comes out somewhere between this range of lengths, they could still use it. But if it's smaller than 241, it might be too small to use. And if it's bigger than 244 centimeters, it might be too big to use. So they want to know, if these are the parameters that their machines work under, what proportion of all the rods they produce are they actually going to be able to sell? And if the proportion here comes out too small, this company probably needs to go back to the drawing board and do some adjustments on its machine so it can get that standard deviation down lower. So let's take a look at how we would find the answer here, and also how we want to write up our work to show how we got the answer and to illustrate what's happening. So let's pull up our whiteboard. And the first thing we want to do is write down our given information. We know that these steel rods have a normal distribution, so we can use statistical notation with that capital N, and then in parentheses, and we list the mean first. The mean was 243.4, and the standard deviation is 0.8. So this would be an important thing to include in your picture, just somewhere in your picture, to have that written down, that shorthand summary of the given information. And then you can go ahead and draw in your normal distribution there. So we want to start with our horizontal axis. I can make a straight line there for our normal distribution. And then above that, show our normal curve. I'll do the best I can drawing it freehand here on the computer, but you know what that shape should look like, even though if mine doesn't look very good. It should be symmetric, right, with your inflection points on each side. And you know the middle of that curve is the mean of your distribution, so you can go ahead and label that and say this spot right here at the mean would be 243.4. And when we're dealing with numbers like this, with so many decimal digits, you don't always have to go in and label what your standard deviation is, because that's given to you. You've written that somewhere in your picture, so your reader knows, okay, this curve that we're looking at, the standard deviation is 0.8. And now we can fill in the values of interest. This question said, well, what proportion of rods are between 241.9 centimeters and 244.3 centimeters? So we're going to fill those values in too. So, just take any estimate you like, draw a line down and say, okay, this is the first value of interest, 241.9. And here's the second value of interest, 244.3. And they're asking for the proportion of all rods to fall in this range. So we're going to shade in the area in between those two numbers. The thing we need to calculate to solve this problem is we need to figure out, we shade all that in, what is this area? And that's a very important feature of your drawing to show your work here, is to show that area shaded in, both these two values of interest labeled, and then the question we're trying to answer here is, what is that area? So now we kind of got two calculator commands that are helpful for us in these normal distribution problems. There's the normal CDF calculator command and the inverse norm calculator command. So we want to take a minute and think, when do we use each of those? Well, inverse norm is used when we already know the area and we're looking for a value on the horizontal axis. And that's not the case here. We don't know the area or the proportion. So whenever we're looking for an area or a proportion, the calculator command we want to use is the other one. It's the norm CDF command. And I apologize for my handwriting on this computer screen here, norm CDF. And when we do norm CDF, we need to input 4 values. So the first value we want to input is the left-hand boundary of the area of interest. So it's going to be that 241.9. The second number we enter is the right-hand boundary of that area of interest, so the 244.3. And then we need to enter two more numbers. We need to enter the mean of the distribution, so that 243.4. And we need to enter the standard deviation, which is 0.8. And then we're going to go ahead and put that in our calculator. So let's see what we get. If we do second VARS, normal CDF will be option 2. And then we enter those numbers, 241.9, 244.3, 243.4, putting commas between each of them, and 0.8. And then I hit enter. And the number I'm getting there is 0.839. So let's write that in. So this is going to be equal to 0.8393. So that would be our final answer there, and it's always nice to take a minute and think about, well, what does that final answer mean? That number is telling us that if this is how my machines work in my factory, if 243.4 is the average length of a rod and 0.8 is the standard deviation, then about 83.9, almost 84% of the rods I produce will be within this range of length. So 84% of them, if we're thinking that's our usable length, 84% of them would be usable. So if you're the manager of the factory, you'll have to decide, well, is that good enough for me? Maybe the ones that aren't in that range I can still sell for a discount, so it's okay, or maybe not. Maybe that's just not good enough, and I'm going to have to go back to the drawing board and figure out how can I get my manufacturing process to be more precise. But this would be your final answer for the WAMAP question. You're going to enter that in WAMAP. And if you're submitting your work for grading, you want to make sure that you have your normal curve drawn in a nicer shape than mine is, but with all these things labeled. The two values that you were given on the horizontal axis, your mean, the shaded area between them, and then what you found as your answer, your calculator command that you used to get it, and somewhere in your picture that given information that this is the mean and this is the standard deviation.